Today we're going to discuss some ways to calculate momentum. We went over it briefly in the other video about momentum. Okay, so when we calculate momentum, we need to know the formula. All right, I always like to write down my formula triangle. Oops, got to write it down correctly. Okay, then I like to write in the units that we use for each value. Okay, because momentum we know is kilograms times meters per second, velocity meters per second, and mass kilograms. Okay, now keep in mind it is simply like any other mathematical formula, but a more massive object, all right, moving at the same velocity as a less massive object will have more momentum. Okay, so more massive object, meaning an object that has more mass, and a less massive object, if they have the same velocity, the more massive object will have more momentum. Okay? Now, if we have objects with the same mass, okay, moving at different speeds, the object with greater speed will have more momentum. So the object with the same mass with different speeds, okay, the object with more speed will have more velocity. Okay, just give you a couple more examples. We did the, let's do the, if we have a 30 kilogram cart, okay, moving right at 10 meters per second, and a 5 kilogram cart moving in the same direction at the same velocity, each cart will have different momentums. All right? If we plug this in, we get 30 kilograms times 10 meters per second. It would have a momentum of 300 kilograms times meters per second. Okay? If we have a smaller cart or a less massive cart, doesn't necessarily have to be smaller in size, you will have a smaller momentum. Okay? And that would equal 50 kilograms times meters per second. And that makes sense if you think about it. If you think about football, if you're looking at the professional footballs, if you have a running back that weighs 150 pounds running a 4.5 second 40, and you have another running back who's 250 pounds running the same speed, the larger running back is going to have more momentum. Okay? Now, likewise, let's say you have two objects that are the same mass. So let's say let's talk about a 2 kilogram bowling ball. I'm not really sure what bowling balls actually, what their masses are, but we're just going to go with that. So if you have a 2 kilogram bowling ball moving down the alley, now remember these are vector measurements, so we really should write the direction down. All right? And One bowling ball is moving at 2 meters per second, and the other one's moving at 50 meters per second. They have the same mass, but one's moving much more quickly down the alley than the others. Okay? So you would calculate the momentum, 2 kilograms times 2 meters per second. You would get a momentum of 4 kilograms times meters per second. Okay? The other bowling ball is moving at a much greater velocity. So you're going to have a 2 kilogram mass moving at 50 meters per second. Its momentum is going to be 100 kilograms times meters per second. Okay? So you can calculate the momentum as long as you're given the mass and velocity. If you were given momentum and mass, you could calculate the velocity by dividing. Okay? And you'll see that. You just need to plug it into the formula. Okay? And the word problems will tell you exactly what they want you to calculate. All right, if you have any questions, please come see us. Come ask us questions as we circulate the room while you're working on your task list. Okay? Have a good night.